Hello students, welcome back to my channel. In this video, I am going to discuss in detail about the named reactions involving both alkyl and aryl halides. They generally involves Wurtz reaction, fittig reaction, Wurtz-fittig reaction, Grignard reaction, Williamson synthesis, friedel alkylation, friedel acylation, Finkelstein reaction and Schwarz reaction. So, what is the importance of Wurtz reaction? As we all know that Wurtz reaction is highly useful for the preparation of higher symmetrical alkanes. Coming to the fittig reaction, it is useful for the preparation of biphenyls. Wurtz-fittig reaction involves the preparation of alkyl benzenes, whereas Grignard reaction involves the preparation of Grignard reagent. Coming to the Williamson synthesis, it is highly useful for the preparation of either. Friedel alkylation is useful for the preparation of both ortho and para alkyl halobenzenes. And coming to the Friedel acylation, it is also useful for the preparation of ortho and para acyl halobenzenes. And coming to the Finkelstein reaction, this is highly useful for the preparation of alkyl iodides. And finally, moving to the Schwarz reaction, it is useful for the preparation of alkyl fluorides. That means both Finkelstein reaction and Schwarz reactions are highly useful for the exchange of all halogen. Clear? These are the few named reactions involving alkyl and aryl halides. Let us discuss in brief about each and every named reaction. So coming to the Wurtz reaction. In this Wurtz reaction, alkyl halides reacts with sodium metal in the presence of dry ether to form the higher alkanes. Let us see the general case. So alkyl halides, two alkyl halides reacts with sodium metal in the presence of dry ether and it results in the formation of higher alkanes. And always remember that during the formation of higher alkanes, they are always symmetrical to each other. So, we can prepare only alkanes containing even number of carbon atoms, and this method is not useful for the preparation of alkanes having odd number of carbon atoms. So what is the importance of Wurtz reaction? This is the most convenient method for the preparation of higher alkanes having even number of carbon atoms. Let us see few examples. In the first example, ethyl chlorides. Two molecules of ethyl chloride reacts with sodium metal in the presence of dry ether. Here sodium will be eliminated as sodium chloride and it results in the formation of butane, which is always symmetrical. And in a similar way, when we consider methyl bromide, two molecules of methyl bromide reacts with sodium metal in the presence of dry ether and it results in the formation of ethane, which is also symmetrical. Next, it is also possible to form the higher alkanes by using two different halides and the reaction is called as cross-Wurtz reaction. Okay, so what is the importance of cross-Wurtz reaction? In cross-Wurtz reaction, what happens? Two different halides reacts with sodium metal and it results in the formation of higher alkanes which are not symmetrical in nature. Let us see one example. Here, methyl bromide reacts with ethyl bromide in the presence of sodium metal and it results in the formation of higher alkane. So, can you write the product? Yes, it is C2H5CH3. So, propane can be obtained. It is the major product, but there are two other possibilities. That means whenever we use two different halides For example, if you consider methyl bromide itself may undergo Wurtz reaction and it results in the formation of ethane. In the similar way, when we consider ethyl bromide itself may participate in Wurtz reaction, it may result in the formation of butane. So in this way, whenever if we use two different halides, there is a possibility for the formation of three different types of alkanes. Students, is it clear about the Wurtz reaction? Always remember, Wurtz reaction is highly useful for the preparation of higher alkanes which are symmetrical. Next, coming to the fittig reaction. In this reaction, aryl halides reacts with the sodium metal in the presence of dry ether to form the biphenyl as the major product. So, what happens in fittig reaction? In this fittig reaction, aryl halides reacts with sodium metal to form the biphenyl. So, what is the product here? Biphenyl is the product. Let us see one example. Here, aryl bromide, two molecules of aryl bromide reacts with sodium metal in the presence of dry ether and it results in the formation of biphenyl. Is it clear about the fittig reaction, students? Next, we can consider Wurtz fittig reaction. That means it is the combination of Wurtz and fittig reaction. So in this method, what happens? Can you guess, students? Alkyl halide reacts with aryl halide. So Wurtz reaction is applicable to alkyl halides, whereas the fittig reaction is applicable to aryl halides. So Wurtz fittig reaction means it is applicable to both alkyl halides and aryl halides. So in this reaction, alkyl halide reacts with aryl halide in the presence of dry ether to form the corresponding alkyl benzenes. Is it clear about the Wurtz fittig reaction? Let us see one example. So in Wurtz fittig reaction, what happens? Aryl halide reacts with alkyl halide in the presence of sodium metal which results in the formation of alkyl benzene. Let us consider chlorobenzene. So here chlorobenzene reacts with methyl chloride. Can you guess the product? Yes. You try to guess the product. It results in the formation of toluene. With the elimination of sodium chloride. Is it clear, students, about the Wurtz fittig reaction? Now let us discuss about the Grignard reaction. In this Grignard reaction, alkyl halides reacts with magnesium metal in the presence of dry ether and it always results in the formation of Grignard reagent. What is the general formula of Grignard reagent, students? It is RMgX. Let us see one example. Let us consider ethyl bromide. It reacts with magnesium in the presence of dry ether. Then what happens? Yes, it results in the formation of Grignard reagent, that is ethyl magnesium bromide. Students, is it clear about the Grignard reaction? Always alkyl halides reacts with magnesium metal and it results in the formation of Grignard reagent. Let us consider Williamson's synthesis. So in this method, what happens, students? Alkyl halide reacts with sodium alkoxide. So here alkyl halide is reacting with sodium alkoxide. Then what happens? Sodium halide will be eliminated and thus it results in the formation of ether. And always remember that this method is useful for the preparation of ethers which are symmetrical and also unsymmetrical. Let us see two examples. Here let us consider ethyl chloride. It reacts with sodium ethoxide. And can you guess the product? You just eliminate sodium chloride. Then it results in the formation of butane. Ether. Is it clear, students? So, in Williamson synthesis, what happens? Alkyl halide reacts with sodium alkoxide and it results in the formation of ether. So, in this example, what is happening? Ethyl chloride is reacting with sodium ethoxide and it results in the formation of ether. In this case, it is diethyl ether with the elimination of sodium chloride. Is it clear, students? Let us see one more example where ethyl chloride is treated with sodium methoxide. Okay, then it results in the formation of unsymmetrical ethers. Let us see the product. C2H5. Here what happens? Again sodium chloride will be eliminated. You just join ethyl group with methoxy group. That means it results in the formation of ethyl methyl ether. And what is the byproduct formed, students? NaCl. When you compare the first product with the second product, first product is the symmetrical ether, whereas the second product is the unsymmetrical ether. Students, is it clear about the Williamson synthesis? Next, we will discuss about the Friedel-Crafts alkylation. As we all know that in this method what happens? The aryl halide reacts with alkyl halide in the presence of anhydrous aluminum chloride, which results in the formation of two isomers. One is the ortho isomer and the second one is the para isomer. Students, what is meant by Friedel-Crafts alkylation? In this Friedel-Crafts alkylation, what happens? Aryl halide reacts with alkyl halide in the presence of anhydrous aluminum chloride and it results in the formation of ortho and para isomers. Here, para isomer is highly stable and hence it is the major product. Why para isomer is highly stable? Here the two bulky groups are far away from each other and it gives stability to the molecule. When you move on to the ortho isomer, the two bulky groups are adjacent to each other. Due to shielding effect, this ortho isomer becomes unstable. So it is the minor product. Let us see one example. Chlorobenzene reacts with methyl chloride in the presence of anhydrous AlCl3. Now guess what is the major product. So here also undoubtedly both ortho and para isomers will be formed. But remember students, always the para isomer is the major product. So let us write the para isomer. So the para isomer is the major product. And what is the minor product? That is the ortho isomer. Students, is it clear about the Friedel-Crafts alkylation? Now let us move on to the Friedel-Crafts acylation. In this Friedel-Crafts acylation, what happens? Aryl halides reacts with acyl halides in the presence of anhydrous AlCl3. It also results in the formation of both ortho and para isomers. As like in the case of Friedel-Crafts alkylation, here also the para isomer is the major product whereas the ortho isomer is the minor product. Why? Due to shielding effect, the ortho isomer is highly unstable and hence it is the minor product. Let us consider one example. Here the chlorobenzene reacts with acyl chloride in the presence of anhydrous AlCl3. Can you guess the products? Initially you just write the major product. So what is the major product, students? That is the para isomer. It is the major product. And what is the minor product? Undoubtedly, the ortho isomer is the minor product. So, during Friedel-Crafts alkylation or acylation, para product will be formed as the major one. Next, we will discuss about the reactions which involves halogen exchange. So, there are two such reactions, one being Finkelstein reaction and the other one is Schwarz reaction. In Finkelstein reaction, what happens? Especially the alkyl chlorides and alkyl bromides can be converted into the corresponding alkyl iodides on treatment with sodium iodide in the presence of acetone. Is it clear, students? In Finkelstein reaction, what happens? Alkyl chlorides or alkyl bromides can be converted into corresponding alkyl iodides when treated with sodium iodide in the presence of acetone. So here alkyl halide reacts with sodium iodide in the presence of acetone and it results in the formation of alkyl iodide. Let us see two examples. Here ethyl bromide reacts with sodium iodide and it results in the formation of, students, will you guess the product? Yes. Just halogen exchange takes place and hence it results in the formation of ethyl iodide. And what is the byproduct, students? Sodium bromide. Similarly, whenever the butyl chloride reacts with sodium iodide in the presence of acetone, what happens, students? Here also the exchange of halogen takes place and hence it results in the formation of butyl iodide with the elimination of sodium chloride. So simply in Finkelstein reaction, what happens? Alkyl iodides are obtained as the major products. Clear, students? Next, we will discuss about the Schwarz reaction. In this reaction, alkyl chlorides and bromides are converted into corresponding alkyl fluorides on heating in the presence of metallic fluorides. Here, what type of metallic fluorides can be used? Especially silver fluoride, mercurous fluoride, cobalt fluoride or antimony fluoride can be used as the reagents. Let us see two examples. Here the methyl bromide reacts with silver fluoride at 100 degrees centigrade. Here also we have to exchange the halogen. So what is the major product, students? Here CH3F. That means methyl fluoride will be formed. And what is the byproduct, students? Silver bromide. Next, let us see one more example. Here, ethyl chloride reacts with mercurous fluoride. Here also we have to exchange the halogen. Then it results in the formation of ethyl fluoride. And what is the byproduct? That is mercurous chloride. Is it clear about the Schwarz reaction? In Schwarz reaction, what is the major product? Alkyl fluoride. whereas in Finkelstein reaction, alkyl iodide is the major product. Is it clear about the reactions involving the halogen exchange? If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.